Hello, I'm Shruti Tyagi from C3 batch of Computer Engineering Department, and today, as part of my Relational Database Management System internal assessment, I will be presenting an overview on the research paper Utility and Design of Relational Database Systems by Thomas J. Dilling, published in 2020 by Elsevier Inc. on behalf of American Society for Radiation Oncology. For the purpose of this assessment, I will go over the following: the introduction, literature review, database implementation, creation of a lung cancer radiation therapy database, conclusion, future scope, and bibliography. This research paper helps us understand the difference between relational database systems and spreadsheets. Spreadsheets for a long time have been used to collect and organize data, but unfortunately, they usually describe only one-to-one relationships. Databases, on the other hand, describe numerous one-to-many relationships and also minimize space and memory and use SQL or structured query language to fire queries and manipulate data. This paper mainly focuses on medical data and it aims to guide a clinical researcher to perform artificial intelligence analysis across large volumes of clinical data to help in medical research. As part of this paper's literature review, we will be discussing the origin of relational databases, disadvantages of spreadsheets, advantages of relational database, and pros and cons of SQL. The origin of relational databases dates back to June 1970 when they were first defined by Edgar Cord of IBM San Jose Research Laboratory. Since then, American National Standards Institute and the International Standards Organization has deemed SQL as the standard language for database communication. Now, there are many open source RDBMS softwares that operate on CORD's principle, such as PostgreSQL, MySQL, and many more. Spreadsheets have been designed to incorporate and analyze one-to-one relationships. They are prone to error and are inefficient to manage. As we can see here in table C, there are 5 entries on the patient. 1, 2, 3, 4, 5. For instance, if let's say patient dies, then there needs to be change in 5 rows for the death date. This makes visualization and reporting extremely difficult and makes the task of updating a huge pain for the database manager. If there are multiple users working on spreadsheets, then multiple versions are difficult to tackle. All these reasons make it extremely difficult to work with spreadsheets. This is where relational database systems comes into the picture. It gracefully manages one-to-many relationships. Each row of a data in a table has a unique identifier called as a key. This prevents any kind of duplications or redundancies, as we can see here. It connects one table to the other table, thus making it very optimized and helps in managing vast amount of data in a much more secure and organized manner. Coming to SQL, which is a standard query language, it is a standardized language with a well-defined community of users, which is simple, portable, and easy to use. It can be used on multiple systems and has a fast query processing feature. Although SQL can be very efficient to use, it gives the partial control to the user and has a poor interface which might be difficult for beginners to use, and hence it can only be used by specialized personnel. SQL is also difficult to scale, which makes it cost inefficient, but on the whole, it's a great language to use for databases. Database contains millions of rows of data and use many open source software to implement a database in a particular organization. It's important to have a discussion with the ID department. The biggest difficulty while creating a database is the data. Some large centers may have data warehouses or some may even have research servers. While setting up a database, it's important to keep security hazards in mind. Setting up a database should not be on a freestanding laptop or a desktop. it should be on a machine which can be backed up across a secured network electronically. In this paper, a lung cancer radiation therapy database was created. Data was procured from Mosaic and even Sweden's department's verification system. More recently, even the data warehouse was used and it was hosted on a Linux-based server. The database management system used was MariaDB, which is a powerful, commercially supported, free open source database system which has many SQL functions and also provides a GUI for database administration. For data administration purposes, it was used, the attributes in the table were basic, demographic information, radiation, therapy, prescription, dates of the treatment, dose delivered, and tumor stage currently. There are about 3 million rows of data on approximately 4,800 patients that spread across more than 170 tables of this database. As we all know, data is the new oil, and large amount of data, if organized in the proper manner, can help accelerate research, especially in the field of medicine. In this paper, we learned how spreadsheets can erroneously be described as any kind of data, and they are usually used to describe one-to-one relationships. On the other hand, relational database management systems are fairly superior and they can be used to save space, use memory in a better manner, and even fire SQL queries. The future scope of RDBMS is the cloud. It's the utilization of virtualization which will help us in future of RDBMS. This does not only help freeing up resources and reducing physical servers, but will also help in increasing our revenue by utilizing superior hardware, and it will help us increase our team performance and increase our income by freeing up resources. Now we come to the end of this presentation. These are the links that were used to prepare the presentation. I would like to express my immense gratitude to all these links for empowering me with the information to present this paper, and even the Department of Computer Engineering for giving me this knowledgeable chance to learn and study this wonderful research paper. Thank you.